As Dr. Ting said, my name is Mel Breyer, and today I will be talking about my thesis project, which involved assessing presence and local habitat connectivity of Franklin's ground squirrels using track tubes and camera traps in central Illinois. Here is an overview of what I will be talking about today. Franklin's ground squirrels, which one is pictured on the slide here, have been listed as state threatened in Illinois since 2004. Overall, populations of Franklin's ground squirrels, or FGS, have been decreasing in the Midwestern United States. These declines have been more prevalent in the southern portion of the species range and can be widely attributed to the loss and fragmentation of tallgrass prairie and savanna habitats due to intensive agricultural practices. Habitat fragmentation reduces the amount of suitable habitat for FGS from large land tracts to small isolated patches. These small isolated patches are less likely to be colonized or recolonized. Hubishman 2007 suggested that the failure of dispersers to encounter established populations may be a primary cause of the species decline in this southern portion of the range. Right-of-ways, or ROWs, can serve as dispersal corridors. Dispersal corridors provide a path along which extinction-prone populations can move and can allow for the persistence of populations. In Sangamon County, there are 4 types of ROWs: abandoned railroad, active railroad, power line, and roadways. And in Sangamon County, Franklin's ground squirrels can be found along some of these types. Overall, the use of live trapping for detection can be laborious and relatively costly. A less labor-intensive but still reliable means for detecting FGS is ideal for surveying a wide area for its presence. Using Sangamon County as a testing ground, I used alternate detection types, track tube sampling and camera trapping, to determine what areas of the county they inhabit. To do this, I utilized track tube sampling and camera trapping, used occupancy modeling to estimate site occupancy and detection probabilities, measured distance between patches and compared this to suggested dispersal thresholds, and assessed ROWs in Sangamon County for their suitability as dispersal corridors. My overall goal is to help facilitate the conservation of FGS. FGS can be found throughout the Midwestern United States. Historically, they were located through, as I mentioned, the Midwestern United States and into the Canadian provinces of Ontario, Manitoba, Saskatchewan, and Alberta. FGS are not a prairie obligate species as previously thought. They utilize tallgrass habitat, savanna habitat, and alternate habitat types, such as fence rows, abandoned fallow fields, and ROWs. Franklin's ground squirrels spend much of their life in burrows underground and are strictly diurnal. The availability of a place to construct a suitable burrow system is the limiting factor in their distribution. My study consisted of a single season occupancy study of FGS. My season lasted from mid-May to mid-September 2014. I utilized a removal sampling method outlined by McKenzie and Royal. Removal sampling requires that a site may be surveyed a maximum of K times in a season, but once there is an initial detection, surveying of that site ceases. Dugan et al. 2011 conducted 4-day sampling period, independent sampling periods to document occupancy status of FGS in Illinois. For their purposes of their study, each day of sampling represented an independent survey. For my study, each day of track tubing also represented an independent survey with a maximum number of surveys equaling 8, so up to 2 4-day sampling sessions. If FGS were detected, or at the end of a standard 4-day sampling session, track tubes and camera traps were removed from a site and placed at the next site. If they remained undetected after a first 4-day sampling session, there was an additional pattern of 4 days was conducted to try to detect them. Sangamon County was my overall study area. However, I did survey 2 sites in Christian County. Between the 2 counties, I surveyed 14 sites indicated with the white dots on the map. Sites were selected based on their connectivity to known FGS colonies and or their suitability of habitat along the right-of-ways. So that all of the sites were from any of those types of right-of-ways I mentioned. One site was selected based on the fact that FGS currently are found there, and this site was used as a source location for distance measurements. I'll talk more about that specific site later. I used track tubes and camera traps, as I mentioned. Track tubes were constructed using plastic gutter sections, duct tape, and binder clips. Clear contact paper was placed sticky side up onto the inside of the tubes, with 2 ink-soaked felt pads placed on top of the contact paper. A bait that contained a mixture of peanut butter and sunflower seeds was placed on the roof of the tube to encourage animals to walk into them. These track tubes were placed 10 meters apart along each transect, and Bushnell trophy trail cameras were mounted to garden utility posts and randomly placed at some of these locations, or at some of the track tube stations. So there were more track tubes placed than camera traps. I used occupancy modeling to estimate site occupancy psi and detection probability p. I used the single season, single species model of this to estimate these things for FGS during the 2014 season. The single species, single season model has 4 main assumptions. A system is close to any changes in occupancy status during the sampling period. Psi is constant across all sites, or differences in occupancy are modeled using covariates. P is constant across all sites, or is a function of survey-specific covariates. And detection at a site should be independent of detection at other sites. I used program presence to estimate these parameters. Program presence allows for the estimation of site occupancy and detection probabilities, and also uses covariates to try to help explain some of the differences in detection probabilities among surveys. I used ArcGIS to measure the distance between occupied patches and the study sites to compare this to suggested dispersal thresholds. So I found FGS. I detected them at 2 of 14 study sites in the study area. At the first site, Lenhart Isles, this is that source site that I was talking about, FGS were also live tracked and radio collared during the same season. During a survey there, FGS were detected at the first independent survey, so day 1, with both camera trapping and track tube sampling. However, at site 11, the other site where FGS was detected, they were not detected until the 3rd independent survey there. This is likely, the occurrence of FGS at site 11 is likely due to dispersal, not occupation, as the 2 sites are only 1.7 kilometers apart. The average Euclidean distance, or straight line distance, from the source, Lenhart Isles, to each site was 19.8 kilometers. The average distance between the sites, like from one site to the nearest site, was 4.4 kilometers. Here is a photograph of some tracks taken from the Lenhart Isles site of Franklin's ground squirrel tracks. And here is a camera trap detection of a radio-collared Franklin's ground squirrel. Due to my small sample size, I was not able to model for any of the survey-specific covariates. First, I need to go back and explain what survey-specific covariates are versus site-specific. Survey-specific covariates are ones like that may vary within each survey at a site. So the date, I collected for the date, daily precipitation, and maximum and minimum daily temperatures. The site-specific covariates are ones that are not going to change throughout the season. So I collected data on patch size and distance to nearest patch. So as I said, I was not able to model for any of these survey-specific covariates. I did, however, compare the 2 detection methods, the track tube sampling and camera trapping. Overall, there was support for 6 of these 8 models, with patch size accounting for 62% of the AIC weight, and distance to nearest patch only had 46% of that weight. Overall, models where detection probability was held constant ranked higher than the models where the 2 detection methods were compared. The top-ranked model had a detection probability estimate of 64.3% and a naive occupancy estimate of 14.3%. There was also a significant negative value for psi of negative 2.2. However, this value did have a high standard error. When the 2 methods were compared across all sites, track tube sampling was estimated of having a 71.4% probability of detecting for FGS, and camera trapping had an estimate of 57.3% probability of detecting them. This difference could likely be the cause of me having more track tubes out there than camera traps. So camera trapping overall provided a less labor-intensive method for detection, and apart from initial costs, was the most cost-effective, especially if multiple year studies were to be done using these methods. There was this weak negative relationship that I mentioned, so that high standard error of the psi value is likely due to having a small sample size. Increasing the sample size would help provide more precise estimates, but increasing the number of survey days is not necessary, as it would only increase the standard error of the estimates. If you were to increase the number of sites surveyed, however, that would be more beneficial. There were a few occupied patches within a dispersal threshold of 8 kilometers cited in the literature, and in a Euclidean dispersal distance of 9.7 kilometers from here in Sangamon County. The suitability of the ROWs in Sangamon County, too, varied across right-of-way type, with abandoned railroad and roadsides being more suitable than active railroad and power line corridors. The availability of suitable habitat is also subject to mowing practices done by the farmers and the Illinois Department of Transportation. So I believe that the presence of these right-of-ways, like suitable habitat along the right-of-ways in Sangamon County, only increases the level of landscape connectivity from low to medium or low to moderate. The degraded quality of remaining Franklin's ground squirrel habitat in Sangamon County provides a challenge for further conservation efforts. Conservationists are challenged with the task of making a place for Franklin's ground squirrels without threatening farmers' livelihoods in an agriculturally dominated landscape. Further educating farmers of the ecosystem services provided by prairie and savanna habitats may help preserve and restore these habitat types in Sangamon County. I would like to thank all of the people who are part of this study, Dr. Ting, and the other members of my thesis committee, Dr. Roos and Dr. Clinchern, Dennis O'Connell and Kim Trebet at IDOT for helping me get permits to survey on some of these right-of-ways, Tracy Evans for allowing me to survey on her land, Greg Humphrey at the Sanitation District for letting me also survey on their land, and Charlie Ford for helping me get some of the GIS layers that I needed, and also all of the people listed on the right for helping me in the field or with any questions I came across. Do you guys have any questions?
We have a minute for questions.
Sorry.
Any questions for Mel?
If these there's
a question.
Okay.
I'm sorry. Are you going to be planning to do any more with this, or is this it?
It was just a one-season study.
Okay.
But it doesn't mean that we will not continue.
Mm-hmm.
This is a long-term project, right?
So if you do continue, how may the research continue in the future besides just maybe looking at more sites?
That's a very good question, because the next step is we're actually trying to do a habitat suitability modeling to really try to identify all the sites, and based on what we know about the dispersal ability of a Franklin ground squirrel, and then trying to do a model, incorporate into the model, and to see that it's possible that we can rely on solely a one-source population to get to those areas, or we need to get involved some kind of translocation efforts to establish additional source populations at a larger landscape. Yeah. Right.